On a scale of 1 to 10, I think the degree of difficulty with this project was probably a 9.
The whole operation started with picking the method that we were going to use, whether it was going to be the build in place, which was an option in the contract plans. The second option was to do a build off-site and float in. So with that, once we decided that based on the schedule and the time frames that we had and costs, we went with the float in option.
The old bridge was built around 1950, and it was designed for much lighter trucks than we see now. And over the last, 50, almost 60 years, it's deteriorated significantly.
We had to lower the weight limits on the bridge, and we actually put some what I call Band-Aids on there. There were big steel Band-Aids on the bridge to keep it together. We had engineering done, and a number of folks look at it and realize that it did need to be replaced.
Well, when we designed the project, we allowed the contractor the option of either building the bridge on site or building the bridge off site and then floating it into position. But one of the constraints on them was that under either circumstance, they had to keep the channel, the navigational channel there, open except for a few days.
Between the two options, being able to go with the floating option allowed us to work here at the site, at Sauvie site, at the same time be able to be working down at Terminal 2. And that allowed us to have that all going on instead of having to have the superstructure of the box girders completed before we could ever even start bringing the iron out and start the assembly of the arch. So the time frame that the owner gave us for completing the job site and getting it done in the time frame we were looking at, the option to float stood out quite prominently. And the other reason is to be able to do both sides at one time, we would have to have the crews manning both sides of the river. We'd have to have equipment on both sides of the river. We'd basically have to have everybody attacking it from both sides at one time, and that required a lot of manpower, equipment, and costs.
When the bridge was being designed by a consulting team, David Evans and Associates was doing the design, but there was a lot of cooperation with the county on the design, and we really didn't have any environmental issues with the float-in method. Our main requirement on the contract drawings, the contract plans, was that they work out a scheme ahead of time and submit it for our approval before they went ahead with the work, to make sure that it had all been thought out and they wouldn't get to a point partway through the job where they find out things wouldn't work well. So that was really our main requirement, that they have an approved scheme for doing it.
Finding a dock or a place that we could build the arch to allow us to be able to get it onto a barge was important to do. We were able to do that with Port of Portland, and we were able to then go through and get the engineering done to make sure that the dock would hold the arch during the assembly and all the skidding equipment that we needed, that we were not going to have any problems with the capacity of the dock itself. Once that was established, then we had to start working with Dix and Norsar and FOT to start figuring out how it would be assembled, how it would be lifted, how it would be floated. And once we were able to determine all that, the object is to be able to assemble it on site, skid it, jack it, move it with the minimal amount of internal bracing, external bracing. FOT did very well on the fabrication. Building out at Terminal 2, FOT really had to concentrate and do well on their quality control and quality assurance, which they did a very, very good job. They came up with a good submittal for doing the shop assembly at their shop in Tigard. They were able to put it all together. Everything was matched. When it came out on site, we did not drill or ream a hole. We were able to stuff every bolt on the job. The barge that we finally ended up settling on is a 300-foot barge, 84-foot wide, 19-foot of freeboard. The arch itself was 365 feet long, 80 feet high, approximately 60 feet wide.
Well, as the bridge was being built, we were working with Dix and Cooney on how do we launch this bridge now? How do we get it aboard the barge? And we were working with Norsar Company, and I think they were in charge of that. How do you transport this bridge from the dock onto the barge?
The method that Dix used to move the arch assembly from the dock to the barge was a skidding system that is used for moving dry docks, moving cranes, moving several different heavy items of that nature. It consists of timbers on the ground that are dispersing the load, typically 90 degrees to the skid system itself. The skid system rolls along with arms that are able to grab onto the skid rails themselves, and they pull themselves along hydraulically. So you've got these arms that come out to these dogs, grab them, and they pull themselves along on the rail, which then above that are all the support beams and cribbing beams, the header beams, that hold the actual load of whatever it is that they're moving. In our case was the arch span. On the barge itself, there were 4 sets of towers that we had to bring our system out onto that system. And it had to land separately each time onto the different towers. As we would land on a tower, the dolly system would roll back, grab another point, bring it out to another set it down, come back, grab again, go out. So we had to line the barge up with FOSS on the tugs and get our alignment so that we were exactly right using winches and the tugs and different cables on the bollards on the dock. The decision to jack up the bridge at Terminal 2 in lieu of jacking it up here at the site hinged a lot on the fact that we have all these houseboats in the vicinity, and the width of the channel would not allow us to come up the channel, make the 90-degree turn with the arch down low without taking out some of the buildings. So we needed to be up high to clear the buildings you see behind me.
So it really was not feasible to do it here the same way that Fremont was, to lift it straight up into place because of the piers are in the way. So that left them the options of floating it in, somehow getting it high enough to float over the top and then landing it. And I've worked on lots of jacking operations, but I'd never seen one like this. I think it's something that they've invented themselves and worked very well here, and that was to use stacks of wood to support the load as it's jacked into the air. So that there are other ways to do it, but that's a very efficient method that they've worked out. Now, so the jacking system consisted of 4 steel towers, one in each corner of the barge. And the purpose of the steel towers was to keep the stacks of wood from tipping over. The arch was actually supported by stacks of hardwood. And as they jacked it up in the air, they had a very tricky jacking system that would jack the span up about 8 inches, and then they would put in 2 layers of 4x4 hardwood blocks and slip those in, and then land the load on that, and then they could jack up another 8 inches and put 2 more layers of hardwood in. So they ended up going, the actual jacking height, the amount that they lifted was somewhere around 50-some feet from where it was on the barge when it started until it finished. So they ended up with stacks of timber that were somewhere in the neighborhood of 50-some feet tall. So the steel towers did not carry the weight. The steel towers were just there to make sure that these 50-foot tall stacks of wood didn't fall over. You also see some sloped pipes alongside the steel towers, and those are there to brace the towers. Without those pipes, the towers could just fall over. So the steel braces on a slope down to the barge deck are there to hold it.
So in this process, we had to move the barge probably 3 different times. Stand by it while they were loading, put it alongside T2 while they were jacking it up, take it back out, flop it around, bring it back into T2 again. So our operators that were going to be involved with moving, the actual movement of the bridge, had a good feel of how the barge felt, even when it was jacked halfway and then when it was jacked all the way up. They knew how stable the barge was just by grabbing it and moving it. I think the biggest concern was when they came to me and showed me a drawing of the bridge being jacked up. And that was my biggest concern first. And I told them that, okay, we can do this, but we're going to have a surveyor sign off on this to make sure that the barge is stable. Because when you look at something like that with a human eye, you're going, well, this is kind of inconceivable. How do they do that without that tipping over? So we go through steps to make sure that that's, a stable platform for us to be pushing down the river. And the weather is the other thing, because when the river's level rise here on the Willamette, and the river levels rise on the Columbia River, the dams are dropping lots of water, what happens is the Columbia River will back up the Willamette River. And so the Willamette River out here, there's no way for the water to escape like it normally would into the Columbia, so the only way for that water to escape is through Sauvie's Island Channel. So the current through the channel can be quite fast. We had 4 tugs that we used on this. 2 of them were what we call a tractor tug. And the reason we call it a tractor tug is because the propulsion underneath the tug, instead of being an open screw type, is actually a unit that sticks down, 2 on each boat, that provide 360-degree azimuthing. In other words, the direction of the boat can go forwards and backwards and sideways through the water by using these units. Each unit rotates 360 degrees. Both the Z-Drive boats had 3,000 horsepower. We had an understanding with the contractors that once we began our transport of the barge with the bridge aboard to the site, that my captains would be totally in charge of the movement, and if they felt uncomfortable with anything, they thought that something was unsafe, that they would put a halt to the operation until whatever it was that they felt unsafe with was corrected. The primary boat in this was the PJ Briggs. That's where most of the commands came out of. He was the primary boat, the Daniel the secondary boat, and then the 2 conventional boats were operating under direction from the primary boat. Well, as they were approaching the mouth of the Sauvie's Island Channel, and as they were making their turn into Sauvie's Island Channel, I was watching the flag, and what I was noticing with the flag was that the wind was dying down. And then once they entered the channel, I was wondering if the flag was going to flutter around from one direction to the next direction, and then that would tell me that the winds were eddying around in there. But what I saw was that it was nice and calm, and I just breathed a sigh of relief that we weren't going to have any wind issues, because we didn't have much space on either side of the new bridge piers, and for them to actually lower that down into that position and hold it as stable as they did for the length of time they did, I thought they did an excellent job. The time it took from when we left Terminal 2 and felt comfortable with the tow and then arrived at Sauvie's Island was probably less than 2 hours.
The day of the float went very well. We had poor weather during November and December. The day of the float, we actually had the sun come out, and the travel down, once we heard them on the radio talking that they were releasing the barge from Terminal 2, and the way that they were able to float out and come down the river was quite a sight. Passing under the Burlington Northern Railroad Bridge was something. The big thing for Max J. Cuny Company was to see us pass underneath the St. John's Bridge, which we had just completed as the previous contract to this. Also the sight of seeing well over 500 people lining the highway on Highway 30 at different junctures through. If there was a side road, if there was a hill, if there was a place to park, people were parked. They were taking photos. When we got to the job site, the dike that we're on right now was just lined with people. Traffic was parked clear down the road. It was quite a sight to see all the excitement and that everybody showed, and the day went very well.
You know, we managed to do this project without cutting off access to the island. People were able to come and go through all of the seasons. The farmers were able to carry their products across the bridge. The project really went well in keeping it accessible to everyone.
I'm very pleased with how it all ended up, and give enormous credit to the whole contractor team that put the whole operation together.